in question 3, we're looking at matrix transformations, and one of the key points to remember with here is, especially for the first part, 0, 0, minus 1, is this column is the image of the point 1, 0, and this column is the image of the point 0, 1. And you can use that to work out what's been going on. So 1, 0 has stayed where it is, 0, 1 has gone to 0, minus 1, so it's gone down there. So that is a reflection in the x-axis. Right, the second one, we want to look at our formula book, which this is the formula you're given in the formula book. As we can see, matrix B matches this, so that means cos theta is a half, and sine theta equals a half root 3. So therefore, if we do inverse sine on that one, we get theta is 60 degrees. And if you do in your calculator, or just by knowledge, inverse cos of half, theta equals 60 degrees. So that means it is an anti-clockwise rotation through 60 degrees about the origin. You do need to check the sign, not just use inverse cos, to make sure you get an angle that fits both values. Right, so then on C, we've got the point 1, 0 is going to the point 0, minus 1. So that's by looking at the first column. Then we've got the point 0, 1 is going to negative 1, 0. It's not a rotation, as it doesn't fit the rotation matrix anyway. So what this is, and if you look at the arrows, both going different directions, this is a reflection. This is a reflection in the line y equals negative x. Now D is a 3D matrix, so now we've got the first column is where the point 1, 0, 0 goes, and as you can see, that's gone nowhere. Now 3D is going to be a little bit trickier to draw. Or you might just want to learn some of these. So the point 1, 0, 0 stayed where it is. The point 1 unit up on the y-axis, that's the second column here, that's gone to 1, 0, 1. So that's moved there onto the x-axis. And the point 0, 0, 1 on the x-axis has gone to the point 0, minus 1, 0. So the y's moved to the z's moved down to the y. Now this means it's actually a rotation. The other way you can work this out is you're going to have to learn a matrix, because these aren't in the formula book. Okay. So one way is to try and think about it and think about what it looks like. The other way is to learn this rotation matrix. As you can see, a rotation about the x-axis means obviously the point 1, 0, 0 doesn't go anywhere. Okay. And then you can see where the points on the y and z here. Notice that this is very similar, or in fact exactly the same as our 2D anti-clockwise rotation here. So this is a rotation, which you can see from the diagram or by remembering the matrix. So it's a rotation around the x-axis, as that stayed where it is, it stayed invariant, by, and then that's theta is going to be 90 degrees. Now the other way with this is, if you look at the matrix, cos theta equals 0, sine theta equals 1 by matching up this formula with the matrix we've got. Inverse sine, inverse cos on those give the angle of 90 degrees. It is anti-clockwise. So there we go.